Hey guys, and welcome to your next Advanced C++ and Graphics tutorial. Today we are actually going to be compiling and linking the shaders that we created in the previous tutorial using GLSL. So what we need to do is go ahead and create ourselves a new class. Let's go to our graphics tutorials and we're going to click Add Class. And the class that we're going to make is going to be called GLSLProgram. So this is going to be a program that runs our GLSL code. Now what GLSL is, I'm not sure if I fully explained this, but GLSL stands for OpenGL Shading Language, and it's the programming language that we used in the previous tutorial to create our vertex shader and our fragment shader. And the reason we need to use GLSL is because that's what programming language OpenGL needs to run things on the graphics card. So there's two things we need to do with our GLSL program. First, we need to compile the program, and that's where we take all this text that we wrote and we compile it into a form that our graphics card can actually use. And then we need to link the program, which is going to take our vertex shader and our fragment shader and basically link them together into one shader program that the graphics card can use. Now we need to do this so that we can, color our triangles and things like that. In the previous tutorials we created just a white box using two triangles. Some of you may not have actually been able to see that box because on some graphics cards you need to have a shader to actually be able to draw things. So after this tutorial you should be able to get a red box or a blue box or whatever, and then we'll move on and do a lot of other really cool stuff with shaders. All right, so let's go ahead and get started on this GLSL program. So the first thing you want to do is make a function that compiles the shaders. So we're going to say void compile shaders. And the parameters for this function, I'm going to make it just be two strings that specify the file path for our fragment shader and our vertex shader. So what this function is going to do is it's going to read our vertex shader and our fragment shader from file, and then it's going to compile them into a format that OpenGL can use. And luckily, we don't have to do anything really complicated to compile it because there are OpenGL calls that will compile it for us. So let's go ahead and do the file name. So we're going to say string, and the first one is going to be the vertex file path. So we'll say vertex shader file path, and that's a really long name, but that's okay. I like verbose names. It's easier to understand what's going on. And then we're going to do another std string, and this will be fragment shader file path, like that. So let's do std here. And to get string, we need to include string at the top. There we go. All right, so another thing we can do here is because these strings are never going to change, we can make them constant, and that will prevent us from changing it so we don't have any bugs. That's just a safe thing to do, good programming practice. And also, right now these are not by reference, so what's going to happen is we have to copy the strings every time. So if it's a really big file path, we're kind of wasting time doing a little extra copying. What we can do instead is make it a reference parameter, and since it's constant, we're going to know that we're not going to change the original copy. So we're just going to use the original copy here, and it'll be a little faster. You're not going to notice it at all, but it's just a good habit to get into. And we'll put the semicolon. And the other function we want to create is void link shaders. And this is what's actually going to link our shaders together into the final program. Now we do need some private variables. And just like with the vertex buffer object, you need an ID to basically hold on to your actual shader program and your individual shaders as well. So what we need to do is say GLuint, and we're going to call it program ID. And to get GLuint, remember we have to include glglew.h. And if you're on Mac, you'll probably just include gl.h. So this will be the ID that is basically the handle for our entire OpenGL program, which is the, oh, my mouse is doing some weird things right now. Oh God, what's going on, you guys? All right, that was weird. So the program ID is basically the ID that refers to the entire program, so the finished product. And then we also need two more IDs, GLuint ID, or this will be the vertex shader ID, and then GLuint fragment shader ID. Now, just like the vertex buffer object, we should remember to initialize these to 0 in the constructor. And now normally whenever we initialize things, we've been doing it just in the body of the function like this. We've been going what is it, program ID equals 0. But there's another thing you can do that's slightly faster than this. It's a good habit to get into. It's called using an initialization list. And this only works for constructors. But what you can do is go right here to the right of these parentheses here and put a colon. And then you can, for each of the private variables that you want to initialize, you can type the name and then parentheses. And then inside the parentheses, you put what you want the value to be. So we're going to put 0 here. And this prevents basically one extra copy. It's not going to cause your program to be any faster really at all, unless this is a constructor that's getting called, you know, thousands of times per frame. But it's another thing that's just a good habit to get into. So this is called an initialization list, and from now on, I'm going to be, and I can't type and speak at the same time, as you can see, I'm going to be using this to initialize all our variables from now on, because it's a good thing to do. All right, so that will initialize all 3 of them to 0. You always want to do that with your GLuint IDs. And pretty much every object in OpenGL needs a GLuint ID. Vertex buffer objects, textures, programs, everything has its own GLuint. All right, so let's go ahead and copy these 2 functions down here, and we'll go ahead and get started writing them. So we're going to do what we usually do. We're going to copy this, and then we're going to move the get rid of the semicolon and put the body. All right, so let's start with just compile shaders, because that's the first step in this. So we pass in the vertex shader file path, fragment shader file path, and we need to open the files, read in the data, and then compile the shaders. So how do we do all of this? How do we actually compile the shaders? Well, luckily, we have the World Wide Web that can give us plenty of information here. If you just Google OpenGL shader compilation, you're going to get taken probably to the main OpenGL page that teaches you exactly how to compile shaders. This is the basically reference documentation that you can use to do this all by yourself. You could even skip this tutorial and come here and just figure it out all on your own. You could come here to, they have actually an example that you can pretty much copy paste and modify to fit your needs. But since I'm a nice guy, I'm going to walk you through the documentation one step at a time, and we're going to create our shader program compilation stuff. So first thing we need to do, the very first step for shader object compilation is this GLuint GLCreate shader. And we call this once for each type of shader. And for us, we're just having a vertex shader and a fragment shader. You'll see right here, the parameter, which is a GLenum shader type, can be one of these values. And the only ones we care about are GLVertexShader and GLFragmentShader. So let's go ahead and open up the code. And we're going to say, sorry, I'm a little allergies right now. All right, so we're going to say GLCreateShader. And it's going to be GLVertexShader. And this returns a GLuint, and the GLuint this returns, we are going to store in vertexArrayID right here. So vertexArrayID equals that. Now, anytime we have an OpenGL call that returns a GLuint, they pretty much always return 0 when there's an error. So we're going to say if vertexArrayID is equal to 0, then what we want to do is print an error message and quit the game here. But we can't call, remember we wrote our fatal error function, we can't call it here because we defined it in main game. So what we need to do is, instead of copy pasting this, which would be really bad programming practice, what we need to do is make ourselves an errors file. So we're going to make a new item. I'm not making a new class, I'm just making a new item. And we're going to say errors.h. And then let's also make an errors.cpp. So I'm going to add another new item. This will be errors.cpp. So in errors.cpp, we're going to include errors.h. And in errors.h, we're going to add a pragma once. Or if you are if you prefer to use include guards, you can do that as well. All right, so in here is where we are going to move our fatal error function. So what I'm going to do is put the prototype in the header file. Now we could define the whole thing in the header file, but that would require us to include extra things in the header file, and you always want to include as few things as possible in the header file. If we do it this way, all we need is the std string, so we're just going to include string. Now in the CPP file, we're actually going to define the function. So let's go ahead and grab this, and I'm going to delete it from there, and we're going to put it here. And so this is the fatal error function. Notice we are missing a few things. We need include iostream, and we need include SDL.h, just like that. And I think that should be good. There we go. It'll call SDL quit, all that. Now there's one more thing I need to teach you. Normally whenever we do forward declarations, that's what this is right here. we'll be doing it like in main.cpp. We'll have like a for declaration up here, and then we'll have the body of the function down here. But whenever we're doing it where the for declaration is a completely different file, like for instance the for declaration is in errors.h and the actual definition is in errors.cpp, we need to add the keyword extern on the front, and that basically just tells the compiler that this fatal error function is defined somewhere else. We don't need to do that in classes like GLSLProgram because it knows where it's contained whenever it looks in the CPP file and sees this GLSLProgram : like it can figure that out. You don't need to use the extern in that case. All right, so now if we want to use errors, all we have to do is include errors.h. So let's go back to main game, which was using it, and let's include errors.h there. And then in the GLSL program, we can include errors here. Errors.h. There we go. So now down here we can say fatal error, and we can give it an error string, and we're going to say vertex shader failed to be created. Alright, so that will print an error message and exit the game. Now let's do the same thing with the fragment shader. I'm going to just copy paste this. Now keep in mind, copy pasting is very dangerous because you can copy paste something and then forget to change something and then you've got an error. So usually I advocate for people never to copy paste, even though I do it all the time. But in this case, this is a really simple copy paste. So it should be pretty easy for you to figure out what things you need to change. We just need to change these two things, this part, and then this should be fragment shader. All right, so that's going to create a vertex shader and a fragment shader. Now what we need to do is actually load the code from our files, and here we have this function GLShaderSource. That's what specifies, basically we're giving OpenGL a pointer to our code that we want to compile. So first thing we need to do is we need to load all this. And to do that, we can just use an if stream. This is something we're very familiar with. It's not going to be the fastest way to load this, but it doesn't really matter right now. We're not going to notice much of a difference in performance because this is just two very small shaders. So let's go ahead and include fstream here. And then we're going to create ourselves an if stream down here. We're going to say if stream vertex file, and it's std, if stream vertex file. So you can, in the constructor, you can put the file path, or you can do on a separate file, vertexFile.open. I'm going to use the constructor, and I'm going to say in here our parameter vertex shader file path, just like that. So that will open it, and then we should always check if vertexFile.fail. If it fails, we should do a fatal error. So we're going to say fatal error, and we're going to say failed to open. And what we can actually do is with normal strings, because this does take a string, with strings you can actually combine two strings together with the plus key. So I'm going to combine failed to open and the vertex shader file path in this string. So what it's going to do is it's going to say failed to open shaders slash color shading.vert or something. It's going to be a much better error message. And we can also, if we wanted to, we could do a p error. If you guys remember p error, this will also print another error message out for us. So we're going to get two error messages that are printed out, and this one is going to be more specific to the actual problem. So it'll probably tell us something like the file name could not be found or something like that. All right, so that will open it up. Now what we need to do is read all of the data from the file into one string. So basically we're taking this entire file and we're putting it in one string variable, and that string variable is going to get compiled by OpenGL. So let's go ahead and say string file contents, and it's std string. Got to get in that habit. And now whenever we're reading a file line by line, we're going to be using the getLine function. So we need to read each line into another string. We'll call it std string line. And now to do the actual reading, all we got to do is say while, and hopefully you guys remember the tutorial where we used std getLine, and we're going to read from vertex file, and we're going to read into line. So each time we do this, if it is successfully able to read a line, it's going to return a positive number. Otherwise, it's going to return 0 and it's going to end. And remember, 0 is the same thing as false. So each time we do that, and let's go ahead and initialize file contents to the empty string here. Equals, my keyboard is being weird now too, equals the empty string. So each time we do that, we're going to say file contents plus equals line, because remember you can combine strings with the plus. We can append strings or concatenate them. We're going to say file contents plus equals line, and we're going to add a new line, because whenever you call getLine, it does not grab the new lines. It just reads to the new line and gets everything before it, but it doesn't actually get the new line. So we have to remember to add that on. All right, so that will put everything in file contents, and at that point, we can go ahead and close the vertex file. So we can say vertex file.close. If we forget to do this, it's not too big of a deal. It will close once the vertex file object here is destroyed, which will happen whenever we return from compile shaders, because this is a local or a stack variable. Because remember, we learned about the stack and the heap. All right, so that will close the file. Now we need to actually use this function right here, GL shader source, and this will tell OpenGL, hey, here is where you're going to get the source for this this compilation. So let's go ahead and say GL shader source. Now the parameters it takes is first it's going to take the shader ID, which in our case is this vertex shader ID. So I'm going to copy that right there. Comma, now it takes the count, and this stands for the number of strings, and in our case there's just one string. We just decided to put all of the text in one string. And now we need a pointer to the C string of vertex file. Now unfortunately there's something weird where if you type ampersand, file contents.cster, this gives you an error. I'm not exactly sure why. We could probably Google it and find out. But there's a little hacky way to get around it. If you say const char star, we'll just say file pointer or contents pointer equals this file contents.cster like that. Then we put the address of contents pointer right there. Then that will be fine. And contents has an S. There we go. There we go. So this is like a little hacky way to get around that. Basically what OpenGL wants here with this address of a pointer is it wants an array of C strings. Now if you remember, a C string is a char star. It's basically an array of characters. Now we are using a normal string, but you can get the C string from that by just using .cster. And in our case, we only have one string, so we're not actually using an array. However, it still wants us to pass it as if we had an array of C strings. So essentially, we are passing an array that is one C string. So we need a pointer to the C string. And then last but not least, it asks for this pointer to an array of integers that's going to be the length of each string. But since we only have one string, we can just type null pointer here, and that's fine. Well, there we go. That's going to do the shader source. Now we need to actually compile the shader. So if we get on here, you're going to see there's this call to GL compile shader. So all we have to do is say GL compile shader, and we're going to say which shader, and that's the vertex shader ID, just like that. And bam, that will compile our vertex shader. Now we need to do the same thing for the fragment shader, but first let's do a little error checking because we could have done something weird in color shading.vert. For instance, we could have put an extra D in there, or I remember in one of the previous videos I had a lowercase p. We want to be able to see what our error is, and we want it to tell us what we did wrong. So what we can do is do a little bit of error checking here, and it actually gives us an example here. We can use this GL get shader IV, and what this stands for is basically get an integer value, and we're asking for the integer value GL compile status from OpenGL for this shader. So we're going to basically ask, what was the status of the compilation? Did it work? Did it not work? So let's go ahead and do that. We're going to copy paste this right here. Let me grab it. And we're going to put it in graphics tutorials like that. So shader is going to be vertex shader ID. All right, now it returns, I believe, a true if it works. So there we go. Here's an example right here. If is compiled is equal to GL false, and they're actually not being consistent here, which is kind of funny. They use success here and they use is compiled here. So we're going to say if success is equal to false, then we do all of this stuff right here. So I'm just going to copy paste this so we don't have to type everything ourselves. We're going to paste that right here, and is compiled for us is actually success. Shader is vertex shader ID, and we need to include vector here. So let's go ahead and include vector. There we go. So we have std vector of chars, which is pretty much actually the exact same thing as a string. We could have used a string here. In fact, let's go ahead and use a string instead. Should work fine for us. And max length. Actually, I guess string doesn't have the right constructor for that. So we're going to go ahead and use a vector. So what this is going to do is going to create a vector of chars, which you could think of as being like a string. And it's going to make it so that the size of the vector is max length. And it's going to get max length from this GL get shader IV GLInfo log length. And what this GLInfo log length is it's the length of the log that OpenGL is creating whenever it compiles. So if it has a bunch of errors and things, it's going to build this log, and this will be the length of that log. And then this function call right here, glGetShaderInfo log, will actually take that log that OpenGL created and it will put it in this error log little string thing. And glDelete shader here should be vertexArrayID. So let's go ahead and do a fatal error here. Shader failed to compile. Vertex shader failed to compile. And before we do that, let's also print out the error log. So I'm going to use, instead of cout, and we don't want to return here, instead of cout, I'm going to say std printf. Hopefully you're familiar with printf. And I'm going to just print a string with a new line, and that string is going to be the address of error log 0. So error log inside is an array of characters. So remember, an array of characters is the same as a C string pretty much. So if we say the address of the very first element of error log, that's like saying we just want this to be interpreted as a string. And this will print out our vector of characters as a string. It's a really cool trick. And we probably could have made this work with a normal string, but we're doing it this way because it's an opportunity for you to learn. All right, so that's that. That's going to compile the vertex shader. Really, really nice. Now we need to do the same thing with the fragment shader. So let's go ahead and I'm going to pretty much do the same thing we did here. So we're going to do, instead of vertex file, we're going to do fragment file. Now you'll notice this is pretty much all going to be copy pasted. So what we should do instead of copy pasting this is we should create a separate function that is just called compile shader, and it will compile one shader. So let's do that. Let's make another function. This will be a private function. We don't want to be able to call this from anywhere else. We're going to say void compile shader, and we're going to say constant std string, and this will be file path. And then the next variable we need is probably going to be this right here, what type of shader it's going to be. And actually, we don't need to do that. We can just create the shaders here. So actually, I think that might be all we need. Yeah, so let's go ahead and try that. So let's go ahead and copy this to the file. We're going to put it below link shaders here. And I'm just going to grab all of this stuff below that, and I'm going to paste it down here. There we go. So this is going to work fine. Now, instead of vertex shader file path, we're going to replace that with file path. Very simple. Instead of vertex shader ID, here's what we needed to pass in. We need to pass in the ID. So we're going to say GLuint, and I'm going to make it a reference parameter ID. So we're passing in the exact ID, just in case it would need to change. And actually, I don't think it needs to change, so we can actually not make that a reference. So let's go ahead and copy this down here to compile shader. And this is a way for our code to be more modular. So we are saving time here, so we don't have to write so much code. We can reuse the same code. So anytime we see vertex shader ID, we just replace that with ID, just like that. And now the only thing we need to change is we can't say here vertex shader failed to compile. We're just going to say shader failed to compile. And what we can do is add file path here, and we can say shader file path failed to compile. So it'll be something like shader shaders.whatever.vert failed to compile. Very awesome. So now this code is reusable. So here in compile shaders, all we got to do is say compile shader with what is it? Vertex shader path. And if you type control space, by the way, it will autocomplete for you. And then the ID is going to be vertex shader ID. And then compile shader, fragment shader file path, and then fragment shader ID, just like that. So that will compile both of our shaders. And that is step one in creating our little GLSL program. Now the next step is to actually next step is actually to link the shaders. And remember, linking is when we combine them into one program, because right now they're two separate compiled objects. So we actually believe there is some example. Here is a full compile link. This will show us how to do pretty much everything. So right here is where we start doing the linking. It's going to we can pretty much copy this stuff again. So let's go ahead and do that. We're going to grab all of this stuff from GLProgram all the way down to GL_Shader, and we're going to modify it for our needs. So we copied that. I'm teaching you how to be awesome programmers here with copy paste. And so first thing we want to do here is instead of saying GLuint program, we're going to use the program ID we already created. So this program ID equals GLCreateProgram. And I'm going to keep these comments in there because they're pretty helpful. Now for GLAttachShader, what this does is it takes our shaders and attaches them to the program. It's pretty intuitive. So instead of vertexShader, it's going to be vertexShaderID, and this is going to be fragmentShaderID. And then program, of course, is always program ID. We could do Control F to do find and replace here, but I am going to just do it this way because I'm pretty quick with that. And with Vertex Shader, we want to replace any instance of Vertex Shader with that. With Fragment Shader, we want to do the same thing, replace all Fragment Shader. There we go, Shader Program. That is going to be program ID again. Pretty sure. Did I completely miss that? Shader Program and Program. That's strange. They have a different variable name for shader program and program. I think that might actually be a typo on their part. That's weird. I'll get back to you if that's supposed to be that way. All right, so there we go. This is going to pretty much link it. Let me walk through this one step at a time. First, we create the program ID. Next, we attach the shaders to our program. And finally, we call link program, and this does the linking. See how easy that was? That's all you have to do to linking. All the rest of this ugly code right here is just error checking. So just like we did with GL compile status, we have this GL link status variable here that we can get from OpenGL, and we'll store it in is linked. And we're going to say if it's not linked, even though we just called linked, that obviously means something is wrong. So we're going to do the same thing with max length here in our vector of, this time I use GLchar. This is a really inconsistent example, several very inconsistent examples. It's pretty weird, so I'm going to change that to a char just to make it consistent. So we do this vector, we get the log info. Now we need to print it out ourselves because their example doesn't print it out, and we can actually just copy paste pretty much exactly what we did here, where we just print out the error log and we do our own fatal error. So let's grab that and let's put it, what are we doing? Right here. No, actually we should do it right here at the bottom, just like that. And it's called info log in this case. I'm going to rename that to error log because I prefer the name error log personally. And then we don't have a file path here, so we're just going to say shaders failed to link. Email shaders failed to link, exclamation point, because we are yelling the error at them. And we're going to delete the shader here. You always need to remember to delete your shaders when you're done with them, just to free up resources. Now down here we're calling GLDetachShader. After we link the program, once we actually link the GLSL program, we can now detach the shader IDs because we are no longer needing them, and then we can GL delete. I'm not sure why they don't show you to do this. We can also delete the shader IDs. So we need to delete the vertex shader ID and delete the fragment shader ID so that we can be sure that we are returning all the resources that we don't need back to OpenGL so they can be reused later. And there we go. There's our little GLSL program. We are almost done with it. There's one more thing we need to do, and that is to bind this input right here, this input vertex position. Now if we go here, let's see, there should be a little, here we go, before linking. So between compilation and linking, we can do these four things. Now the only thing we care about is vertex shader input locations. Transform feedback is not something we're doing. Program separation is not something that we're doing. Fragment shader output color numbers is done automatically for you, so we don't need to do that. So we're going to go to vertex shader input attribute locations, and it'll show you there's these two things we can do. The first one you'll see is layout location equals 2. Now this is something that is only used in OpenGL 3.3 and up. We are using OpenGL 3.0, so I'm not going to show you this way. If you're using 3.3, you can feel free to use this instead, but we're going to use this. It's not any slower or anything like that. It's just a little bit older way to do it, and it's perfectly fine. So what this does is it binds our attributes, and these inputs right here, for instance, our position and eventually per vertex color, those are called vertex attributes, and we have to actually bind those to this string. We have to basically say that this vertex position input right here is going to be our first attribute. So we need to have a function that will bind attributes. So we're going to make a function, and we'll call it, we'll say void add attribute. And there's a few ways we could do it. We could explicitly say which attribute we want to add, but I think what I want to do instead is just to make it to where it will automatically add the attribute into the next available slot. So the order in which you call add attribute will be important. So let's say const std string attribute name. So this will be the name of the attribute. In this case, we're going to be saying it's vertex position. So we'll copy that, and I'm going to go into our file here, and we're going to put it right below link shaders. And we need to say that it's, oh, we forgot to do this, GLSLProgram : compile shader here, and add attribute. Always got to remember to do that. All right, so in here, what we're going to do is we're going to have a variable up here. So we could say int num attributes. This will be counting the number of attributes that we have. So if we wanted to add color to this, we would have 2 attributes. If we wanted to add textures, we might have 3 attributes. So for now, we just have 1. That's fine. We're going to go into the GLSLProgram constructor and make sure we initialize this to 0, like that. And actually, it's good practice to initialize these in the order that they are displayed. So it should be initialized num attributes first, then program ID, then vertex shader, then fragment shader, because if you don't, sometimes your compiler will complain to you, because sometimes the order will matter with certain structures. It doesn't matter with these. Okay, and where's that function? Here we go, add attribute. So the function we want to use is called glBindAttributeLocation. So what we're going to do is say glBindAttributeLocation. And the first one is the program ID. So we're basically binding to this program, obviously. Next, we say what the index is. And in our case, the index is going to be 0 for vertex position. If we added in vec3 color or something, this would be the index position 1. If we said in vec2 texture coordinates, this would be vertex location 2. So 0, 1, 2, it's just a 0 indexed array. It's pretty much the same thing. So all we have to do here is use our num attributes variable. So we're going to say num attributes for our index. So it'll start out at 0, and the name will be attribute name.cster, because it asks for a pointer to chars, which means C string. And then what we should do is say num attributes plus plus. So the next time we call add attribute, it will be 1. The next time we add it, it'll be 2, and so on. And something we can actually do to make this a little smaller is we can take this plus plus here and put it on the same line here. If you have plus plus after num attributes, what it's going to do is it's going to add 1 to num attributes, but not until after this line of code. So whenever this line of code runs, it's going to be 0. And then after it's done running, then it will become 1. If we take this plus plus and we put it at the beginning, so this is a prefix instead of the postfix, in this case, it will also add 1, but this time it's going to add before the line of code runs. So with the plus plus in front, we are going to get 1 for the first time, and we don't want that. We want it to be 0. So let's go ahead and make it plus plus at the end. But that's just some little extra information. I don't think you can do this. Actually, it looks like you can't do that, unfortunately. You have to pick one or the other. All right, so that will add an attribute. So now we can actually compile our shaders. We are good to go. This is a good little program, GLSL program. We're going to make it more complicated in the future. Right now it's pretty simple, but that's fine. So let's go to main game. For now, just for simplicity, let's go ahead and include our shader up here, our GLSL shader, include GLSLProgram.h. And we're going to make a program and store it here. We'll probably want to put it somewhere else later, but for now, just for simplicity, it's fine. So GLSL program, and we're going to call it color program. So this will be just the basic color program. Color shader program, I like that. No, that's too long, just color program. All right, so color program is going to be just a member variable, and it should be an underscore, obviously, since it's a private variable. Now what we want to do is, in init systems, we want to initialize the shaders. So let's make another function, void init shaders, like that, and we're going to call this from init systems. So init systems is going to call init shaders right at the end. You want to make sure you call this after you've initialized OpenGL, which we do up here, init shaders. And I will put it right here, and it belongs to main game. This will initialize our shaders. So what we want to do is first compile our shaders. So we're going to say color program dot compile shaders. And the first thing we need is the vertex shader file path, and we put our shaders in, here we go, graphics tutorials, This is basically the base directory that your Visual Studio automatically uses. It's in the directory with your VCX project. So we're going to say shaders slash color shading.vert for the vertex shader. Shaders slash, oops, it's lowercase, I believe, color shading.vert. And then for the fragment shader, we're going to say shaders slash color shading.frag. There we go. So let's make sure that I did type that in right. I have a very bad short-term memory. There we go, color shading.frag and vert. That will compile them. Now we need to add our attributes. So we'll say color program dot add attribute. And the name of our attribute here is vertex position. So we're going to say vertex position. And then finally we need to say color program dot link shaders. And that's it. That's going to set up our color program. That will compile it and link it, and we are all good there. Now, what we need to do is actually be able to use the program. Now, there's this function called GLUseProgram, and this will basically tell OpenGL this is the shader program we want to use. We can only be using one program at a time. So let's go ahead and add some functionality to GLSLProgram. We're going to write the function void use, and this will just use the function. And then we also want to write a void unuse, and this will unuse it, or unbind it, I guess. So we're going to go into our public functions here, put it down here, very simple, and GLSLProgram : use, GLSLProgram : unuse. Now whenever we use it, we're going to call GLUseProgram, and we're going to use the program ID. And whenever we unuse it, we call GLUseProgram on 0. That's the same thing as using no program. And we're getting a little error here. Expected a semicolon. No, you don't. It's yelling at me for no reason. All right. So that will use it and unuse it. Now there's something else we need to do. We need to enable this vertex attribute little array thing here. And I don't think it actually shows us how to do it here. Oh, this is in the vertex shader. GL enable. Yeah, so it doesn't show us how to do it here, but I will teach you how to do it. What am I doing? Here we go. What we need to do is enable each vertex attribute that we have bound here. So all we got to do is basically loop through each of the indices and bind that index, or enable that index. So in our case, we just have only one of them. So what we can do is use a for loop. For int I equals 0, I is less than num attributes, I++. So for each of these, we have to enable it. Otherwise, our shader isn't going to be able to use it. So we're going to say GLEnable vertex attrib array. And we're going to enable I. So since our num attributes is only going to be 1, since we just have one attribute, this is going to run just one time, and we're going to enable vertex attribute array 0. And then whenever we unuse the program, we need to do the same thing. We need to loop through it, and instead of enable vertex attribute array, we need to do GL disable vertex attribute array. If we don't do that, we can run into some really weird issues. Some graphics cards, it won't be an issue, some it will. So we should just always remember to do this. So now what we can do is go into our main game here. Here we are, draw game, and we're going to say color program dot use and color program dot unuse. And there we go. That should do the trick. It's quite possible that I forgot something, so we're about to find out if it crashes or anything like that. If it does, I'll pause the video and fix it. Let's keep our fingers crossed, you guys. Hopefully it's going to work just fine. And there it is, first try again. I am on a roll. So there is our little red square using our wonderful shader. Let's play around with it a little bit. Let's change the color to magenta, which is 255 red, 255 blue, if you are familiar with RGB color codes. And remember to convert it to a range from 0 to 1. You just divide that by 255. Probably just confusing you by saying that. There we go. We get magenta. And yeah, so that's all we're going to do in this tutorial. In the next tutorial, we're going to play around with shaders more. We're going to learn about uniform variables and things like that, and we're going to make shaders that are really cool. We might make some like shaders that change the colors over time and things like that, and we're going to learn a lot more cool stuff. So thanks for tuning in. Sorry this was such a long video, but this was a pretty complicated concept. Stay tuned for the next one. See you later, guys.